So far, we have found sums and differences of polynomials, and now we're going to take a look at how to find the product, or in other words, how to multiply polynomials. So we're just going to break this section up in 3 different parts. So the first part we're going to do is we're just going to look at how to multiply monomials to a polynomial. So remember, a monomial is just a polynomial with one term. So when we multiply monomials, we are going to be applying the distributive property. And that ensures that every term in the first polynomial is multiplied to every term in the second. And when we do this, recall the following exponent rule when we multiply two of the same, when we have exponents that have two of the same bases, like x and x, we can add the exponents together. Alrighty. So taking a look at example 1, let's find the product of the following polynomial expressions. Looking at example 1, we have 3 times the quantity n plus 3. And we've actually seen this before. We've already done things like this, where we distribute in that 3, and then when we do that, we just get 3n plus 3. And that's your final answer. Taking a look at example number 2, I encourage you to pause the video and try this on your own. And assuming you have given it a go, let's go through it. So here, all we have to do is simply just distribute in that -2. So we're going to have -2 times x squared. And then we're going to add -2 times 3x. And when we do that, we get -2x squared. And then -2 times 3x is -6x. So we're going to do plus -6x. And recall, whenever we add a negative, that addition sign changes to subtraction. So our final answer is going to be -2x minus 6x. Taking a look at example number 3, we have -y squared multiplied by the whole expression y squared minus 3. So let's first start off by distributing in that -y squared. So we get -y squared times y squared minus, we're going to bring down that negative sign here, minus 3 times -y squared. And when we do that here for this first term, we're going to have -y, and then because we have the same base, they're both y's here, we can go ahead and combine those like terms, and we're going to add those exponents. So we're going to have y to the 2 plus 2 by using that power rule. And then here we're going to have minus 3 times -y squared becomes -3y squared. So simplifying this out, we're going to get -y to the 4th power. And when we subtract a negative, remember that becomes a positive. So we're going to have -y to the 4th plus 3y squared. And now taking a look at example number 4, I encourage you to pause the video and try this on your own. And let's go through this together. So, as always, we're going to distribute in what's out in front. So we're going to distribute in that -2w. So we get -2w times w cubed plus 3w times -2w plus, or in this case, minus 2 times -2w. And now when we simplify this out, this first term here, we're going to carry along that -2, and then w times w cubed is the same thing as w to the power of 1 plus 3 using our exponent rules. And then here, 3 times -2 is going to be -6. W times w, that becomes w squared. And then here we have minus 2 times -2 is negative 4. So we're going to have negative 4w. Now simplifying this out a little bit more, we're going to get negative 2. w1 plus 3 is w to the 4th power. Then we're going to add, well here actually, when we add a negative number, recall that changes to subtraction. So we're going to have minus 6w squared. And then here, when we subtract a negative number, that changes to addition. So we're going to get plus 4w. And that's your final answer. Alrighty, so now let's take a look at multiplying binomials. And recall a binomial is a polynomial with two terms. So there are different methods to multiplying binomials. However, actually, alrighty, so now we're going to take a look at multiplying binomials. And recall binomials is just a polynomial with two terms. And there are different methods to multiplying binomials. However, I will be teaching the box method. I did cross this out. I was going to teach a different method before, but I decided that we're going to go with the box method. And you will end up learning the FOIL method later in the course. But the box method is just a good method to start off to help you kind of like understand what's happening here when we multiply these binomials. Alrighty, so without further ado, let's take a look. So for example 1, we have y minus 4 times y plus 2. So to multiply this out, I'm going to first start off by drawing a box. And then in this box, I'm going to draw a vertical line down the middle, and then a horizontal line down the middle of the box, or on the side of the box, like so. And then what I'm going to do is I'm going to write this first binomial here, this y minus 4. I'm going to write that on top where the y kind of aligns with this first box here. And then I'm going to align that negative 4 with this side here. And then I'm going to bring along the y plus 2 onto the side. So we're going to have y here, and then we're going to have that plus 2 here. And now what we're going to do is in each box, we're going to multiply the two parts that correspond with where that box is. So taking a look here at this first box here, we're going to multiply y and y. And y times y, recall using our exponent rules, that becomes y squared. And then here, this box here, we're going to do y times negative 4. And y times negative 4 is just negative 4y. And then here, in this box, we're going to do 2 times y. And 2 times y is 2y. And then here, in this box, we're going to do 2 times negative 4. And 2 times negative 4 is negative 8. And now once we get here, all we simply have to do is we're going to write out what's in these boxes. So we have a y squared, a negative 4y, a 2y, and then that negative 8. And now we have to see if we can combine any like terms. And we can combine this negative 4y and this positive 2y. So this becomes y squared minus 2y minus 8. And that's it. Using the same exact steps that we used for example 1, I encourage you to try and pause the video and try this on your own. All the steps are exactly the same as we did here. It's just now we have a variable that's squared. But all that's going to change here is just like a little bit of what our terms will look like, but the process is exactly the same. And assuming you have tried it on your own, let's go through it. Okay, so as always, first step, draw a box. I'm going to bring this binomial y squared minus 2 I'm going to bring that up top. So we have y squared and then minus 2 over here. And I'm going to carry along that y plus 2 on the side. And now here, for this box here, we're going to do y times y squared. And using our exponent rule, we're going to get y cubed. And then here, we're going to have y times negative 2. And that becomes negative 2y. And then here, we're going to have 2 times y squared, which becomes positive 2y squared. And then here, we have 2 times negative 2. And 2 times negative 2 is negative 4. And now let's just write our terms and see what we have and see if we can combine any like terms. So we have that y cubed. Down here we have that positive 2y squared. Here we have negative 2y. And then on the bottom here we have negative 4. And looking at this polynomial, now that we have it written out, there aren't any like terms. So this is your final answer. Taking a look at example number 3, we have x plus 1 all squared. So when we have something like this, like a binomial squared, remember that whenever something is squared, that means we're going to multiply itself 2 times. So in other words, x plus 1 all squared is the same thing as x plus 1 times x plus 1. So now that we know that, let's go ahead and multiply these two binomials. So start off by drawing that box. We're going to have x plus 1 and x plus 1 here. And in this box here, we're going to do x times x, which becomes x squared. Here, we're going to have x times 1, which is just x. Or if you want, you can write 1x to help you. And then here, we're going to have 1 times x, which is just x. Or like I said, if it helps you, you can write 1x. And then here, we're going to have 1 times 1, which is just 1. And now when we write out our terms, we're going to have x squared plus x plus 1. And notice here, we can combine these two x terms because they are like terms. So we get x squared plus 2x plus 1 as our final answer. Alrighty. And taking a look at example number 4, I encourage you to pause the video and try this one on your own. And now let's go through this together. So as always, let's draw the box. Alrighty, let's bring this first binomial here, 3 minus z cubed, over here. And let's bring the second binomial, oh my goodness, binomial, bring it onto the side. So we have z to the 4th power minus 4. And now let's fill in the boxes. So here we have z to the 4th power times 3, which that becomes 3 times z to the 4th. Here in this box, we have z to the 4th times negative z cubed. And using our exponent rules, this becomes negative z to the 4 plus 3, and 4 plus 3 is 7. So this becomes negative z to the 7th power. Here in this box, we're going to do negative 4 times 3, which is negative 12. And then here, we have negative 4 times negative z cubed. So a negative times a negative is a positive. So we're just going to have 4z cubed here. And now that we have it all filled in, let's just write out all of our terms. So we have 3z to the 4th minus z to the 7th minus 12 plus 4z cubed. Now here, notice our polynomial that we wrote out here doesn't have any like terms, but I'm not going to circle this as my final answer because it is not in standard form. It's always just best practice to write your polynomials in standard form, especially as your final answer. So let's do that. So I'm going to go ahead and write negative z to the 7th power plus 3z to the 4th power plus 4z cubed minus 12. And that's it. Alrighty. So now that we have multiplied binomials, I'm going to go ahead and dive into an investigation because there is a pretty common mistake that occurs with algebra students. So let's go ahead and go through this investigation together. So for example 3, we are told that Sarah was asked to simplify the following expression, k plus 3 all squared. Is Sarah's work correct? And explain your reasoning. So go ahead, pause the video. Sarah's work is right here. Pause the video on your own. Think about whether or not Sarah's work is correct. And once you have written your answer, go ahead and resume the video. So assuming you have given it a go, let's go through this. So taking a look, we could also tell right away, if we look at this example, notice that even though these two examples aren't exactly the same, they're both a binomial squared. And notice here, there's a difference between what we did here. We did the box method, right? And we did x plus 1 times x plus 1. Here, Sarah said, I'm just going to distribute in this exponent and get k squared minus 3 squared. And Sarah's work is actually incorrect. And we can go ahead, we're going to investigate why specifically here in just a minute. But Sarah's work is incorrect because the binomial squared means that we multiply itself twice. Not square each term individually. Okay. So exponents cannot be distributed over addition or subtraction. If we were to have a term like a monomial, or in other words, just like a one term on its own, we could distribute in that exponent like this. But if we have a binomial or anything more than a binomial that has addition or subtraction, we cannot just distribute in that exponent, and we have to actually go through and do the box method. And notice here, notice here, for example, 3, when we did the work correctly, we ended up with this middle term here. And notice here, with Sarah's work, when you just distribute in the exponent, you're missing this whole middle term here. So that's one way you could look at it. And we're also going to go ahead and just do a quick numerical proof. And since we know that variables simply just represent unknown values, we can go ahead and test this rule using real numbers. So we're just going to substitute a value in for k and see why distributing the exponent leads to an incorrect answer. So for example 1, given that k equals 4, simplify the expression k minus 3 all squared using PEMDAS. So since k equals 4, I'm just going to go ahead and substitute it in. So we're going to have 4 minus 3 all squared. And recall, using PEMDAS, we're going to first do what's in the parentheses. So we're going to do 4 minus 3 first. And 4 minus 3, that's just 1. So we're going to have 1 all squared and 1 squared is just 1. Now taking a look at example 2, given that k equals 4, we're now going to simplify this incorrectly. I want to emphasize that this is not correct, but given that k equals 4, let's simplify the expression by actually distributing in that exponent. So we're going to have 4 minus 3 all squared. And now let's distribute this guy in. And here when we do that, we get 4 squared minus 3 squared. And 4 squared is 16. 3 squared is 9. So we end up with 16 minus 9, which is 7. Now notice, numerically, when we use PEMDAS, which we know PEMDAS is correct, right? That's our foundation. We know 100% that the PEMDAS method works. We got the answer 1. Now, when we tried this new hypothetical method, we got a different answer. We got 7. So because these answers don't match, and we know that for sure PEMDAS works, we can't, this method here, distributing that exponent, is incorrect. And that leads us to the last question. Both answers do not arrive to the same conclusion. So therefore, we can't just distribute in the exponent. Okay. So last but not least, let's take a look at multiplying trinomials, and then we will be done with this section. So taking a look at example 1, we have y squared minus 4y plus 4 all multiplied by y plus 2. Now here, the method in terms of going from binomials to trinomials, it doesn't change. We're still going to use that box method. We just now have a little bit more going on because we have 3 terms rather than 2 terms. So let's go ahead and write this out. I'm going to go ahead and put the trinomial on the side here. So we're going to look like this. And then I'm going to draw a line down the middle. So we're going to have y plus 2 here. And then we're going to have y squared minus 4y plus 4 here. So here in this box, we're going to have y squared times y, which is y cubed. Here in this box, we have y squared times 2, which is 2y squared. Here in this box, we're going to have negative 4y times y, which is negative 4y squared. Here we have negative 4y times 2, which is negative 8y. Here we have 4 times y, which is 4y. And then the last box we have 2 times 4, which is 8. And now before I write all these terms out, I'm just going to see what our like terms are in the box, so we don't have to write it all out and everything like that, just because of limited space. So looking in this box here, we have a y cubed. We don't have any other y cubed terms, so I'm just going to go ahead, bring that guy out here. And now looking here at our y squared term, we also have a y squared term here. So I'm going to go ahead and combine these like terms. So negative 4y squared plus 2y squared, that's going to get us a negative 2y squared. Here we have another set of like terms. We have a 4y and a negative 8y. So 4 minus 8y, that's going to get us negative 4y. And then we're just going to carry along that 8. And that's your final answer. Taking a look at our last example, I encourage you to pause the video and try this problem on your own. And assuming you have worked through this, let's go through it together. So we have v cubed minus v squared times v times, or not times v, plus v times v squared plus 2v plus 2. So I'm going to go ahead and draw 3 rows and 3 columns in this box here. And I'm going to go ahead and put this polynomial that's here first. I'm going to bring that down here. And one thing I should have pointed out earlier that I didn't point out is that the order you put the products in doesn't matter. So I could put this trinomial here on the side and this trinomial here on top, or I could put this trinomial on top and this other trinomial on the side. It doesn't matter where you place these trinomials, it will always arrive at the same answer. So if you put this trinomial here off to the side, that's completely okay. As long as you get the same answer, we're good. So let's go through it. And then now, this other trinomial, we have v squared plus 2v plus 2. Alrighty, so for this box, we're going to have v squared times v cubed, which ends up becoming v to the 5th power using our exponent rules. And then here, we have v squared times negative v squared, which becomes negative v to the 4th power. Here we have 2v times v cubed, which that becomes 2v to the 4th power. Here we have 2v times negative v squared, which becomes negative 2v squared. Here in this box we have v squared times v, which is v cubed. I apologize here. This term is incorrect. It should be negative 2v cubed. And then here we have 2v times v, which that becomes 2v squared. Here we have 2 times v cubed, which is 2v cubed. This box here, we have 2 times negative v squared, which is negative 2v squared. And this other box is 2v. So before you write this all out, I'm going to go ahead and tell you a little shortcut that you can do to help identify like terms using this box method. Just know that this shortcut doesn't always work out, but typically it works out the majority of the time when you're looking for like terms. So notice here diagonally, if you look diagonally here, we have like terms because they're both 2v to the 4th power. Here diagonally we have like terms because they're v to the 3rd power. If you look diagonally here, they're also like terms because they're all v to the 2nd power. So once you recognize that, in terms of combining like terms using this box method, it's not too bad. Just when you do that, just make sure that they're actually like terms. Because, for example, looking here, z to the 7th power and negative 12, those are not like terms, so you can't combine those. But here, these are like terms. Here, these are like terms. Here, these aren't like terms. But typically, all of your like terms are always going to be diagonal of each other using this box method. But anyways, without further ado, our final answer is going to be v to the 5th. Combining our like terms here, we have 2v to the 4th minus v to the 4th, which is just v to the 4th. And then here, we're going to have v cubed when we combine like terms. Here, negative 2v squared plus 2v squared cancels, so those like terms cancel. And then I'm just going to go ahead and bring along that 2v, and that's your final answer.